guys, you should have your notes open to the page that says Section 4, Day 2. And let's see, the date today is the 16th. So you'll take notes with these as we go through, and then I'll give you the assignment when we're done. We're not going to do this review one today, so we'll turn to the next page and we'll start. And we're going to continue with what we were working on yesterday when we're solving with problems that involve square roots. So just a quick little review off to the side that I'd like you to write down. Remember, when you're solving a problem involving square roots, we did two kinds yesterday. We had some simple ones where it's just, as easy as this, and we said, well, you isolate that root, and then to undo a square root, you square both sides, and we'd say, well, that means x is 25. And when we ran a check on that, we'd say, well, the square root of 25 is 5, take away 1 is 4, and it checks out. And we also had the kind where we had the square root on both sides, and we said, I'll just make one up here, we said, well, if you want to get in at this one at x, you simply square both sides to pop that root off. And we went through that likewise. Now, I'm not going to finish this one. I'm just going to go dot, dot, dot. Now, I'll give you a minute to write that down while I'm talking. So yesterday we dealt with solving these equations that had square roots in them, and we didn't really focus much on the checking the solutions. But today what we are going to do is we're going to make sure we check our solutions, because sometimes this leads to, we've had this word before, what we call extraneous solutions. And these are solutions that don't really work in the original problem. For example, they might result in, maybe you'll get x is 5. Let's say 25. And maybe the problem says the square root of x is negative 5. And when you go plug that in, well, the square root of 25 isn't negative 5. It's positive. And so we'd say, well, we've got a solution here that doesn't work. So what we're going to do today is we're going to continue solving the same way, but we're going to have to check our answers and make sure that we don't get any that cause us to have any math violations. So the moral of the story today is going to be always check your answers when you're done by plugging them back in, and make sure that you don't get anything that results in a problem. And by that I mean you can't square root negatives, that's not allowed, and you can't do a positive square root like that and get a negative. So we're going to have to really watch out for those things today. So let's go through this one, and we're going to solve it. They're going to get a little trickier than yesterday. So again, we've got this x trapped under a root. So to undo that, we're going to square both sides. So I'm going to square the left, and I'm going to square the right. On the left-hand side, I get x squared. And on the right-hand side, that squaring undoes the root. So I end up just getting the inside guts of that, which is negative x plus 6. Now, this poses a new problem today that we didn't have yesterday. How do I solve it when I have both the x squared term and an x term? I can't get at it with just straightforward algebra like I could up here by just subtracting 2x and getting them all on one side, because I've got a problem with that squared term. So you'll have to remember back to the last couple of chapters, so let's put a set of eyeballs over here, that when this happens, we need to get one side equal to 0. And remember, our choice is we always want to have the x squared term be positive. So we want to move everything so that that remains positive and we get one side equal to 0. So in this case, what I'm going to try to do is go get a 0 over here on the right-hand side. So to do that, I'm going to add x to both sides, and I would get x squared plus x is equal to positive 6. And then I'm going to get rid of that 6 also by subtracting. So I'd subtract 6, and I get x squared plus x minus 6 is equal to 0. And now I've got to figure out, well, how do I solve this? And remember, your fastest form of solving these is to see if you can factor it, which indeed we can. And we've done so much factoring that I know you guys should be able to break that apart really quickly. And now notice I get two solutions. One of the ones that causes a 0 is when x is equal to 2. Another answer that causes a 0 is when x is equal to negative 3. And what I need to do is go back to my original and check these and make sure that they're both viable solutions. And how do I check them? I plug them back in. So what I'm going to do here is take that 2 and go put it in for x right here and make sure it's valid. So we'll run a check. Is 2 equal to the square root of negative 2 plus 6? Well, indeed it is. 2 is equal to the square root of 4. So this one is a good, viable solution. On the other one, I would say, well, is negative 3 equal to the square root of, now I should stop right there, because you never have a case where you take a square root and the answer is negative. The square root of 36 is 6. The square root of 49 is 7. It's not negative. So when I go and plug this in, I actually am going to, I could quit right here and say this is a bad solution. Now if you continued with it, it says up here, again, look where the arrow's pointing, that you take the opposite of that x, which would be 3 plus 6, which is the square root of 9. And if I were to ask you what's the square root of 9, you'd tell me the root is 3. It's not negative 3. So again, today we're going to watch out for some extraneous solutions. And for time's sake, I think because this one's so similar here, I only want to make one video. I'm going to go to the next page and maybe I'll come back to that one if I have time. So let's go to the next page here and let's solve it. And again, we're going to have to make sure we check our answers. So we're going to go the same way we did yesterday. Subtract 7, and I get the square root of 4r is equal to negative 4. And again, to pop that root off, I've got to square the left, and I've got to square the right. Well, that gives me a 4r on the left, and negative 4 times negative 4 is 16. And when I solve that and divide by 4, I get r is equal to 4. Okay? So now watch what happens here when I go check this. Back up to the top. When I go check this, I get the square root of 4 times 4 plus 7 is equal to 3. The question is this true? Well, definitely not. The square root of 16 is 4 plus 7 is 11. So we would call this, again, an extraneous solution. Now this is kind of interesting because you could have actually realized it right from this second equation that we had written here. We got the square root of 4r is equal to negative 4, and I just told you can't take a root and get a negative out. So there is no value of r that I could plug in there and get a negative 4 out when I take the root of it. So you really could have stopped up at the top there if you had noticed that. And again, we call this answer that we got here an extraneous solution. It does not work. All right, so what I'm going to do right now is give you, well, I think I'm just going to go through these simply because I don't know how much time I have on my recorder here. So let's go ahead and solve this. We get negative 6 minus 6. We get negative the square root of 2x has got to be equal to 4. And then we square both sides. And you could divide by negative 1 there too. Either way, it's not really going to matter. When I square the negative, it goes away. A negative times a negative is a positive. When I square the 2 root of x, I get, when I square the square root of 2x, I get just 2x. And 4 squared is 16. So again, I'm just using my normal solving skills, just like yesterday. The only difference is here now when I'm done, I'm going to have to go run a check. Does this work? And I go back up to the top, and I say, well, is 6 minus the square root, I'm going red with my checking here, is 6 minus the square root of 2 times 8 equal to 10? Well, you can see that it's not. It'd be 6 minus the square root of 16, which is 4, and that's not 10. So again, my algebra process gave me what's called an extraneous solution, a solution that really doesn't work when I plug it back in. I followed all my math laws here correctly. And again, usually these extraneous solutions pop out when you're doing like the squaring of a negative. That tends to cause some problems. So the answer to this problem would be that there is no solution. So I would say no solution to that one. All right, so for part B, this is kind of good, the reasoning question here. How can you decide that that doesn't have a solution without going through all the steps? And it's because right here, when you square root any number, you cannot get a negative. Square root of negative numbers don't exist. Okay, there's no such thing. You can't do a number times itself and get a negative. And the square root of positive numbers are always just positive. So this is not possible. So anytime you notice that you get the root of, could be a whole bunch of stuff, but if it says negative 7, you can stop right now and you can say no solution. And if you go through all the solving steps and get an answer, I guarantee you when you plug it back in, it won't work. So let's take that on to the next page here and give this one a shot. So number 3, it says solve each, check your solution. If there aren't any, write no solution. So again, let's take this as we normally would. We'll square both sides to pop that root out. We get 2x minus 1 equals x squared. Again, when I have that x squared in that x term, I need to get one side equal to 0, keeping the x squared positive. So I'd subtract 2x, and I'd add 1. Okay? Then I'm going to factor what multiplies to equal 1 and adds up to negative 2. That's an easy one to factor, and I get x minus 1. This gives me the solution of 1. Okay, so x equals 1. Now today, we've got to run a check on that and see if it works. Maybe it will, maybe it won't. So is the square root of 2 times 1 minus 1 equal to 1? Again, I'm going to remove these bars so you can see what I'm doing. I'm checking it in the black. I'm replacing the x with my solution that I just found. Well, this right here is 1, and the square root of 1 is 1. So that's good. This is a viable solution. It's the answer to my problem. The answer is simply 1. And it worked beautifully. So the last one here, let's approach it the same way. I'm going to square both sides. Okay? It's going to pop that root off. Now, interestingly here, what happens is, when I use my algebra, again, no need to get it equal to 0 or that kind of thing. I don't have x squared and x. I simply have the x. So normal algebra rules apply. And I try to get that variable on one side, and what happens is it disappears. And I get what I would call a garbage answer. There is no time in this world that negative 3 will ever be equal to 5. This just doesn't make sense. I mean, it's a garbage answer. So really what this means is that there's no solution to this problem. I followed my algebra laws and it led me down a path to something that's always false. Now, I would argue that those of you with common sense, when you go back up to the top, notice here that when you're taking the square roots of both of these things and they're equal, it means the guts have to be equal. So really what you're being asked to do is find some number x that when you drop it 3, you get the same thing as when you bump it up 5. And that should make sense to you. There's no number in this world that you can say, okay, I'm going to subtract 3 from it, I'm going to add 5 to it, and it's going to be the same thing. That just doesn't make sense, which is why our algebra led us down to this garbage solution. So, to repeat, just for today, down with the summary, all right? So, in your summary, which I have a couple minutes for, first you're just going to solve as usual, just like we did yesterday. You might end up with a couple quadratic equations. So if you get an x squared and an x term in the problem, make sure that you get one side equal to 0 and then you factor it. It's going to usually give you 2 solutions. And also, we must check our solutions. You have to make sure that you don't end up getting any square roots of negatives, because that's not allowed. The square root of a positive number can equal negative. That's not allowed. Again, there's kind of 3 situations. This is what I mean by this. If you get square root negative 7, you can't have it. If you get the square root of some positive number, let's just call it n, equals negative 8, can't have it. Also, if you get what I call a garbage answer, like 3 equals 7, doesn't make any sense. So there's going to be some situations where you get answers that really don't work. You're going to watch out for them. So the moral of your story today is solve as usual. Watch out for quadratics, because you will need to get them equal to 0 and factor. Again, like right here, I didn't have a quadratic. They're both to the 1st degree, so I could simply solve as usual. And when I'm done, I've got to check my answers. Sometimes you'll get 2 of them and only 1 will work. Sometimes you will get 2 and neither will work. You just have to run a check on them and see if they're correct. Your assignment for today, which you can add to yesterday's, will be page 624, 25 through 36, 43, 45, 57, and 62. And you'll add that to yesterday's homework. Okay, you can turn it all in tomorrow, or if you can get it in by the end of the hour today, maybe I'll give you a little extra credit. If you're having a hard time with these, period 1, ask Mr. Dorholt for a little help. Period 3, ask Mr. Osmo for a little help. Period 5, ask somebody next to you for some help. There's a lot of people in this hour who have really been understanding this stuff, so check your odds in the back, and does somebody next to you, sorry I have a cold, has it. have them help you out. So we'll see you tomorrow and finish that up. Bye guys.